Lesson 14, video number 1, we're doing 6.4 identities involving the sum of trig functions. We've got product to sum identities and we have sum to product identities. Now, we're going to work through these first two problems, 2a and 2b. You'll notice I have made a little notation on problem number 2. Okay, it is sine of alpha, cosine of beta. You'll see an alpha there that's supposed to be beta, otherwise this identity doesn't work out at all. Okay, so make that change again. Sine of alpha, cosine of beta. Now, looking at this identity, okay, very carefully, I'm going to go ahead and zoom out as much as possible here. You're going to notice I have sine of alpha cosine of beta equals to that 1/2 quantity sine of alpha plus beta plus sine of alpha minus beta. And you're looking, or you're thinking, well, let me pull out my identity sheet. And again, during most of these notes, you will see this identity sheet, okay? And if we look very closely, we will see in the product to sum identities that that identity is basically right here in front of us. Now, I want to make something very clear. Just because this is alpha and not x and this is beta and not y does not mean you can immediately say, hey, we're done. Okay? I'm going to say that again. Because this identity is here, and that's what I'm asking you to prove, does not mean you're done. It means I want you to use the identities that are previous to this. Now, on your identity sheet, they will be in order of the way you learn them. So for the product to sum identities, we can use every previous identity that we've learned to prove that identity. And that's what we're going to have to do. Okay? So, let me look at this identity, and let's remember what are the techniques that we always wanted to do. Start with the more complicated side first. Now, sine of alpha, cosine of beta, that's not going to change at all. Okay, that's unfortunate, but it's nice. It's clean. Okay, sine of alpha and cosine of beta are not going to combine in any way. At least I don't know any way that they're going to combine. So what I'm going to do is I'm going to start over here. I'm actually going to start with sine of alpha plus beta, okay? And I'm going to look back to my formula sheet and say sine of alpha plus beta, I have a sum and difference identity for sine of x plus y. So in that x plus y identity, I'm going to change all my x's to alphas and all my y's to beta. So what that means is, I'm going to write this down, that this side is supposed to be equal to 1/2 quantity sine of alpha cosine of beta plus cosine of alpha sine of beta. Okay? And that's honestly what this sine of alpha plus beta is, just by looking at that identity. Again, remembering that my x's are alphas, my betas are y's. Okay? This thing is plus this sine of alpha minus beta. Wait a second. Don't I have a difference identity for that? Yes, I do, right here. Okay. Then I'm going to go ahead and do the same thing with this one, changing all my alphas to x's and all my betas to y, or vice versa. So, this identity is going to give me the sine of alpha cosine of beta minus the cosine of alpha sine of beta. I'm going to put parentheses around that and then my brackets. Okay, let me zoom out here so you can see this a little bit closer, or clearly. And I have this thing, which is really this, okay? And I have this parenthesis, which is really this, okay? Now, I'm going to look very carefully at this. I have sine of alpha cosine of beta plus cosine of alpha sine of beta. There's this piece plus this piece plus this piece minus that piece. Okay? Now, I want you to look very closely at this and ask yourself, is there anything that I can simplify? Can I combine anything here? And I hope you're noticing that the sine of alpha cosine of beta is the same as this sine of alpha cosine of beta over here. So now this is 1/2 times 2 sine alpha cosine of beta. Because I have two of them, why not say it's two of them? And then I'll look at this cosine of alpha sine of beta minus cosine alpha minus beta. So those two pieces are actually going to cancel each other out. There's nothing else in those brackets. Again, these two pieces cancel each other out. Hey, look, that leaves me with 1/2 times 2, which is then sine of alpha cosine of beta. And that problem is done. I'm going to say this one more time. If you see an identity on your homework, test, quiz, anything, and it is an identity directly related to one that's on your formula sheet, I am not expecting you to say, hey, I'm done. I'm expecting you to verify that utilizing previous identities. Okay? So that's 2A. Let's talk about 2B. 2B is this particular problem. The cosine of 2x sine of 5x is equal to 1/2 sine of 7x, parenthesis, plus sine of 3x. So now with this, I can actually use these identities. Okay, it's okay to use these identities here because it's not one directly related. Okay, it's not just changing the variables from x to beta or alpha and beta to y. So let me look at this. I have cosine of 2x and the sine of 5x, cosine of 2x, cosine, and sine right there. I can use this identity, the secondary one. I could actually use this one, okay? And you'll actually notice that there is a slight difference between these two. I'm not going to identify that difference. I am just going to go ahead and use this one, and then we're going to have to use another identity. I want you to see this, okay? So I'm going to use this one right here. Again, you can use this one if you're very careful, but I'm going to go ahead and use this one. So, with that being said, my x up in my identity is really 2x, and my y in my identity is really 5x, okay? So again, maybe you don't see it, but I am visualizing my formula sheet right here in front of me while I simplify this identity. I'm making this notation so I don't screw anything up, okay? It might help for you to write down the identity that you're using. Again, the cosine of x sine of y is equal to 1/2 sine of quantity x plus y minus sine of quantity x minus y. So, I'm going to go ahead and say this thing right here. The cosine of 2x, the sine of 5x is really equal to 1/2 sine of x plus y, where x is 2x and y is 5x. Again, if you're still confused where I'm getting these things, I am looking at my identity sheet. It's right in front of me. So minus, now I have the sine of x minus y, where x is 2x and y is 5x. With that being done, okay, I'm going to go ahead and combine the things that I can. This is 1/2 bracket sine of, oh, that's nice, 7x. And then I have, wait, minus, aren't I supposed to be proving that this is a plus? Well, let's hold on to that fact. I don't want to stop yet. I've already gotten halfway through this. This is the sine of a negative 3x, right? I mean, 2x minus 5x is a negative 3x. And that's a little bit wrong, too. This doesn't add up. This here is not this here, is it? Well, I hope some of you are thinking, taking a minute, remembering sine is what kind of trig function? It's an odd trig function. And with it being an odd function, it has the property that if I plug in a negative function or negative variable, I'm going to get back a negative being pulled out of that function. Okay, so sine is one of those odd functions. This is really 1/2 bracket sine of 7x, and that negative there that's inside the function can be pulled outside. Would be right here now. Okay, so negative is actually going to be positive, and therefore my identity has been proven. I'm looking for this. I have this. Check. And that is the end of problem 2B. We'll come back with video 2 for 4.